So without further ado, can we give a warm West Virginia welcome to Dr. Michael Mann, Admiral David Titley, Dr. Judith Curry, and Dr. Patrick Moore. Dr. Mann, the floor is yours, and I will start the timer as soon as I'm able to pull the app on my phone.
Okay, well, thanks very much. Thanks for doing this event. I'm hoping that we will have a robust conversation tonight about climate change, what's driving it, and indeed it is human activity, and more importantly, where the debate lies, where there's room for a worthy debate, is what do we do about it? And so let me first start by reviewing what the scientific evidence says. The basics behind human-caused climate change are not controversial. It's physics and chemistry that's been known for nearly 2 centuries. The greenhouse effect, certain gases in the atmosphere, like CO2, warm the planet. We are increasing the concentrations of those gases in the atmosphere by fossil fuel burning. This curve I constructed a little more than a decade ago, and it's fundamentally out of date now, because if you look at the vertical axis, you'll see it ends at 390. You have to add 2 more vertical tick marks to that scale now. Here's where we are. We just passed 410 parts per million CO2 in the atmosphere last week, the first time we've crossed that particular threshold. We're fairly confident now that you have to go back millions of years to find CO2 concentrations that were naturally that high. So we are engaged in this unprecedented experiment with the planet, and what we wouldn't be able to explain would be if the Earth were not warming up. But of course it is warming up, as these observations tell us. 2014, 2015, 2016 were 3 consecutive record-breaking years. The good news is that 2017 did not yet again break the record. It was only the 2nd warmest year on record. What's the likelihood you would get 3 consecutive record-breaking years in the absence of human-caused climate change? Well, we actually published an article a year ago actually calculating those likelihoods using climate models and observations, and I could describe the work to you, but I think it suffices to just put up the headline that Discover ran about our findings. The record global warming streak of 2014 through 2016, a snowball's chance in hell that this was natural. It cannot be explained by natural variability, and indeed, when we look at the warming of the planet and we look at the role of natural factors versus human factors, we can't explain the warming. In fact, the globe should have actually cooled in the latter half of the 20th century if it were just natural factors that were at work. So it's happening. Climate change is real, and it is human-caused. It is due to the increase in greenhouse gas concentrations from fossil fuel burning. That is the consensus of the world's scientists. Now, 2 decades ago, as of Earth Day this year, 2 decades ago, we first published this curve, the hockey stick, that depicted our estimate of how temperatures had changed over the past 1,000 years. And what that curve shows is that the warming, in fact, is fairly unusual. This doesn't happen all the time. The warming spike of the past century is unprecedented as far back as we were able to go. It got a name, the hockey stick. It was featured in the IPCC Summary for Policymakers, and it has become somewhat of an icon in the climate change debate. Again, on its 20th anniversary on Earth Day this year, there were articles talking about this iconic graph that is now 2 decades old. And because it did become an icon in the climate change debate, it has been fiercely attacked by those looking to discredit this iconic curve as a means of trying to discredit the case for concern about climate change, even though this is just one in many independent lines of evidence that tell us that climate change is real and it's human-caused. Well, there's now a veritable hockey league, which is to say there are dozens of these sorts of reconstructions that have been done using different methods, different data, and they all come to the same conclusion that the recent warming is unprecedented as far back as we can go. In fact, there's now some tentative evidence that the warming spike of the past century is unprecedented in tens of thousands of years, as far back as even the tentative estimates now go. That's the sort of evidence that's led the Intergovernmental Panel on Climate Change. Again, thousands of scientists from around the world who assess the consensus of what the science has to say, determining that indeed the recent warming is unprecedented in this case. In at least 1,400 years, as I said, there's now tentative evidence it's unprecedented over a much longer time scale. Now, as I said, the hockey stick has continued to be attacked because it was this iconic graph in the climate change debate, and I've written a book about that. It's actually for sale out here. I'd be happy to sign copies of that book afterwards if you're interested. And I talk about experiences as a scientist who studied applied math and physics. Wasn't really a prescription, I thought, for putting myself at the center of one of the most contentious societal debates, but because of where that my scientific training led me in the publication of the hockey stick, I found myself in the center of this very contentious public debate. Now, what about the future? What does the future hold? Well, if we were to basically bring our carbon emissions to a halt or ramp them down dramatically, we could prevent warming the Earth by more than 2 degrees Celsius, 3.5 Fahrenheit, relative to the pre-industrial, what many scientists say constitutes dangerous and irreversible climate change. But if we continue with business as usual warming of the planet, we're talking about anywhere from 4 to 5 degrees Celsius, 7 to 9 degrees Fahrenheit warming of the planet by the end of the century, twice that much in the Arctic because of the amplifying effect of melting ice, a profound change in our climate. Now, it isn't just the warming of the Earth, it's the disappearance of the sea ice, and you'll see a recurring pattern here. The red is the observations, and it shows how sea ice is decreasing over the years. And the shaded region is what the models predict. So yes, the models were wrong here. We're outside of the range of what the models predicted. Sea ice is disappearing faster than the climate models predicted. Yes, there's uncertainty, but uncertainty isn't necessarily our friend. In many respects, we are finding that things are happening faster than we expected. This is where it is this year. It's on course potentially to set yet a new record, although we'll have to see how things shape up over the next few months. There are other surprises. One of the things we're learning, and I've done some research in this area, is that climate change can impact extreme weather events in ways that we didn't really understand years ago. And in some research that I've done, there's evidence that climate change and the amplified warming of the Arctic is actually changing the jet stream in a way that favors very persistent, very large meanders. That's when you get the most extreme weather events, the 2003 European heat wave, the 2010 Moscow wildfires and Pakistan floods, the 2011 Oklahoma and Texas drought and heat wave, the 2016 Alberta wildfires were all examples of extreme summer weather events that were associated with a very specific phenomenon which we show is becoming more common because of global warming. So this is an impact that we didn't understand just a few years ago. We're now understanding that things like these 1,000-year floods that you're hearing about, and of course West Virginia was one of those states over the past few years that's experienced a 1,000-year flood, a flood that shouldn't happen more often than once in 1,000 years, and yet they're happening quite frequently. And that's because climate change is impacting these extreme weather events in ways that actually we didn't even understand a few years ago. So there is uncertainty, but it's not our friend. We're learning about mechanisms that actually amplify the problem. And nowhere is that more true than with the ice sheets. And this is an example of a tipping point. Once you start the melting of the ice sheets, you can't stop it. It sort of gains a momentum that causes it to be irreversible on human timescales. And what we're finding now is that we've warmed the planet enough that some of those very substantial feedbacks are setting in. The collapse of the ice shelves of the West Antarctic ice sheet because of the warming of the southern oceans, which is destabilizing the ice sheet and allowing it to collapse faster than we thought it would. So again, there was uncertainty, and if you had asked us 5 years ago what the best estimate was of the sea level rise we could see by the end of the century, we would have told you 3 feet. And that's not good, but no more than 3 feet. It's not a problem for Charleston, West Virginia, but it is a problem for Charleston, South Carolina. Well, now if you ask us, we have to say it may be closer to 6 to 8 feet. Because when you take some of the processes that were missing in the climate models and you put them into the models, what you find is that ice sheets can collapse more quickly than we thought. So we've literally had to double the estimate of what sea level rise might be by the end of the century, from 3 feet to 6 to 8 feet, just over the past couple years. Uncertainty is not our friend. As we learn more, as we understand more, we're seeing that the impacts can indeed potentially be worse than we had forecast. Of course, some, congressmen think that sea level is caused by rocks tumbling into the oceans. That was a comment made by a congressman a few weeks ago at a hearing on climate change. And then there was an article, an op-ed that appeared in the Wall Street Journal arguing that the sea is rising, but not because of climate change. We wrote a letter to the editor replying to that, pointing out that that's sort of like saying that, objects are falling, but it's not due to gravity. It's absurd. The science tells us that indeed sea level rise is being caused by the warming of the planet, and we explained that in our letter to the editor, and I know that at least one person, we got through to at least one person, because this was the person sitting next to me on a flight that same day, reading our op-ed, our letter to the editor in the Wall Street Journal. So we reached at least one person, near as I can tell. But you still find this sort of denial of the most basic facts in our public discourse. As I said before, there's a worthy debate to be had about what we do about this problem, how we solve this problem. But there isn't a worthy debate to be had about whether the problem exists. The impacts, and I'm running out of time, so let me just say that the impacts are no longer subtle. We're seeing them play out. It isn't just polar bears in the Arctic that used to be the poster child of climate change, but it's about us. It's about unprecedented droughts, and as Dave Titley will tell you, in some cases, these unprecedented droughts are creating stress that may be amplifying national security problems, international terrorism. There is a linkage there. Climate change is what the national security community calls a threat multiplier, and David will talk more about that. And these record droughts are creating conflict that is potentially leading to national security problems. It's obviously impacting our infrastructure, unprecedented wildfires like the California wildfire, the Thomas fire this last winter. And I'm saying wildfire last winter. Well, that's not when wildfires are supposed to happen in California. But that's when California had its worst wildfire on record. And if you talk to the fire managers, if you talk to the folks in California now, they'll tell you, we're starting to question whether or not we can even refer to a fire season in California, because what we now have potentially is a perpetual fire season. That's the face of climate change, not subtle. And landslides, and there was a connection there as well, because if you destroy the vegetation, then when the winter rains come, then suddenly you can have massive landslides like the one that killed more than 20 people in Southern California. And of course, we all know about the unprecedented tropical storm season we had in the Atlantic last year, unprecedented in many respects. And just as we start now on our next season, as we go into the next season, climate change is amplifying some of the characteristics of these storms. That's adding to sea level rise, representing unprecedented threats to our coastlines. And we're all paying the price. The damage that's being done along our coastlines, even for those who live, of us who live inland, we pay for those damages. There's taxpayers ultimately are paying for the damage that is being inflicted by climate change, regardless of where it happens in the country. Can we adapt? Well, we're going to have to adapt to some of the changes that are already baked in. But we don't have the adaptive capacity to deal with climate change if we allow, if we continue on this course that we're on, business as usual, burning of fossil fuels. There's no amount of adaptation that can provide the adaptive capacity we would need to deal with the changes that would be in store. Should we engage in geoengineering, massive interference with the climate system in the hope that we might be able to somehow offset climate change? I think that such prescriptions are potentially very dangerous and wrong-headed, and that only leaves us with one solution. There are things that we can do personally to decrease our own personal carbon footprints, and we should all do those voluntary things. In many cases, they save us money, they make us healthier, they make us feel better. But ultimately, if we're going to solve this problem, then we need to fundamentally remake our global energy economy. We need to begin a transition, we need to accelerate a transition that's already underway, away from fossil fuels towards a renewable energy economy, and we need to take care of the people who are displaced along the way. Whalers were displaced in the 19th century when we went from whale oil to fossil fuels. Something better came along. It was fossil fuels. Guess what? Something better has come along now. It's renewable energy. And we have to help the people, like many of the folks in West Virginia, who are going to be displaced as we undergo this transition towards where we need to go in the future. Thank you very much.
Well, good evening, everyone. I look forward to our conversation this evening. There's widespread agreement on these basic tenets about climate change. Surface temperatures have increased since 1880. Humans are adding carbon dioxide to the atmosphere. And carbon dioxide and other greenhouse gases have a warming effect on the planet. However, there's substantial disagreement about the issues of greatest consequence. Whether the recent warming has been dominated by human causes, how much the planet will warm in the 21st century, whether warming is dangerous, and how we should respond to the warming. Now, there's nothing wrong or bad about scientific disagreement. In fact, the scientific process thrives in the face of disagreement, which motivates. Regarding the disagreement on causes of climate change, on the left-hand side is a perspective of a stable changes in response to changes in atmospheric CO2. In other words, carbon dioxide is the climate control knob. It's a simple and seductive idea. However, some scientists think that this is a misleading oversimplification. They regard climate as a complex, nonlinear, dynamical system with no simple cause and effect. Climate can shift naturally in unexpected ways, owing to natural internal variability associated with large-scale ocean circulations. Now, these two perspectives are not mutually exclusive. Proponents of the natural variability arguments acknowledge the impact of CO2, but consider it to be a modest wedge that projects onto the natural modes of climate variability. The point of this cartoon is that if you only look at one part of the elephant, you will misdiagnose. You need to look at the entire elephant. And the bottom line is that we don't yet have a unified theory of climate variability and change that integrates all this in a predictive sense. Scientific debate actually matter? Well, yes, it does. If you assume that carbon dioxide is a control knob for climate, then you can control climate by reducing CO2 emissions. But if you assume that climate change primarily occurs naturally, then the Earth's climate is largely uncontrollable, and reducing CO2 emissions will do little or nothing to change the climate. My personal assessment aligns with the right-hand side, emphasizing natural variability. However, the IPCC and the so-called consensus aligns with the left-hand side. Up until about 10 years ago, I also aligned with the left-hand side because I thought supporting the IPCC consensus was a responsible thing to do. Here is how and why I changed my mind. In 2010, I started digging deeper, both into the science itself and the politics that were shaping the science. I came to realize that the policy cart was way out in front of the scientific horse. The 1992 UN Climate Change Treaty was signed by 190 countries before the balance of scientific evidence suggested even a discernible human influence on the global climate. Implemented before we had any confidence that most of the warming was caused by humans. There was tremendous political pressure on the IPCC scientists to present findings that would support these treaties, and this resulted in a manufactured consensus. Here's how the so-called consensus and increasing confidence in human-caused global warming became a self-fulfilling prophecy. You find what you shine a light on. In other words, we've only been looking at one part of the elephant. Motivated by the UN Climate Treaty and the IPCC and government funding, climate scientists have focused primarily on human-caused climate change. Other factors important for understanding climate variability and change have been relatively neglected. I've highlighted long-term ocean oscillations and solar indirect effects, since I think these are potentially very important on decadal to century timescales. One of the most consequential impacts of a warming climate is sea level rise. These two statements by climate scientists typify the alarm over sea level rise. The first is a statement by Dr. Jim Hansen. That's the big thing, sea level rise. The planet could become ungovernable. The second is a statement by Dr. Michael Mann. We're talking about literally giving up on our coastal cities of the world and moving inland. Is this alarm justified by the evidence? This figure illustrates the challenge of attributing long-term sea level rise to CO2 emissions. The blue curve shows sea level change since 1800 measured from tide gauges. The red curve shows global emissions of carbon dioxide from burning of fossil fuels. You can see that global sea levels were rising steadily long before fossil fuel emissions became substantial. You can also see that the steep increase in emissions following 1950 is associated with very little sea level rise between 1950 and 1990. Now, an uptick in sea level rise occurred in the 1990s, which is circled. Let's take a closer look to see what's causing this. Since 1993, global satellite data have provided valuable information about sea level variations and glacier mass balance. This figure shows a recent analysis of the budget of sea level rise since 1993. You can see that the overall rate of sea level rise has increased since 1993. Well, what's causing the increase? The turquoise region on the bottom of the diagram relates directly to expansion from warming, but you actually see a decrease until about 2009. Now, this has been attributed to the cooling impact following the eruption of Mount Pinatubo in 1992. What stands out as causing the increase in the rate of sea level rise is the growing contribution from Greenland, which is the dark blue area on top. Hence, the increase in the rate of sea level rise is caused by Greenland melting. So, is the Greenland melting caused by increasing CO2 emissions? The top figure shows the Greenland mass balance for the 20th century. Ice sheet mass balance is defined as the increase from snowfall minus the decrease from melting. You can see the negative mass balance values after 1995, reflecting mass loss that raises sea level. But if you look earlier in the record, you see even larger negative values, particularly in the 1920s and 1930s. Clearly, the high mass loss rates of recent years are not unprecedented, even in the 20th century. Greenland was anomalously warm in the 1930s and 1940s. What caused this? The bottom figure shows variations in the Atlantic multidecadal oscillation, which is an important mode of natural internal climate variability. In general, years with positive AMO index are associated with a mass loss for Greenland, whereas negative AMO index is associated with a mass gain. From this analysis, I can only conclude that CO2 emissions are not the main cause of sea level rise since the mid-19th century. The scientific evidence that I've shown you on the preceding slides is well known to the IPCC. Here are some statements that the most recent IPCC report made on sea level change in Greenland. Recent rates of sea level rise are comparable to those that were observed between 1920 and 1950. Recent temperatures and mass loss from Greenland are comparable to what was seen in the 1930s. Detection of the impact of human-caused warming and observed changes in regional sea level remains challenging. Now, I've been asked to respond to the question, to what extent are man-made CO2 emissions contributing to climate change? The short answer is we don't know. And the reason that we don't know is because we don't know how to disentangle natural internal variability from the effects of CO2-driven warming. Even the IPCC doesn't claim to know exactly. The most recent IPCC assessment report says it's extremely likely to be more than half. More than half is not very precise. Given the IPCC's neglect of multi-decadal and longer timescales of natural internal variability, I regard the extreme confidence of their conclusion to be unjustified. So here's my personal assessment. Man-made CO2 emissions are as likely as not to contribute less than 50% of the recent warming.
5.
If you believe that even if you believe climate model projections, there's still genuine disagreement regarding whether a rapid acceleration away from fossil fuels is the appropriate policy response. One side argues that reducing CO2 emissions is critical for preventing future dangerous warming of the climate. The other side argues that any reduction in warming would be minimal and at high cost, and that the cure could be worse than the disease. What makes most sense to me is climate pragmatism, which has been formulated by the Hartwell Group. Climate pragmatism has 3 pillars: accelerate energy innovation, build resilience to extreme weather, and no regrets pollution reduction. These policies provide near-term socioeconomic and environmental benefits and have justifications independent of climate mitigation and adaptation. These are no-regrets policies that do not require agreement about climate science or the risks of uncontrolled greenhouse gases. I would like to make a few comments on the state of the scientific and public debate on climate change. Here's my take on the madhouse effect. The madhouse that concerns me is the one that has been created by some climate scientists. The madhouse is characterized by rampant overconfidence in an overly simplistic theory of climate change, enforcement of a politically motivated manufactured consensus, attempts to stifle scientific and policy debates, activism and advocacy for their preferred politics and policy, self-promotion and cashing in, and public attacks on other scientists that do not support the consensus. Maybe I should write a book. In closing, I would like to make a personal statement to clarify my motives. I regard my job as a scientist to critically evaluate evidence and to continually challenge and reassess conclusions that are drawn from the evidence. A year ago, I resigned my tenured faculty position because of academic political pressures that interfered with doing my job. My resignation was a direct result of the science madhouse effect discussed on the previous slide. I'm now working in the private sector as president of Climate Forecast Applications Network. My direct engagement with the public is via my blog, Climate Etc., where we discuss a broad range of topics related to climate science and policy. All viewpoints and perspectives are welcome. I hope that you'll join us at judithcurry.com. Thank you.
I'm going to start not with science graphs and all that kind of stuff. I want to show you a picture of my hometown. This is Schenectady, New York. I don't know if anybody knows where that is. It's in upstate New York. Used to be known as a city that lights and halls the world. And this is what it looked like when I was a very young child. This is what Schenectady looked like when I was leaving the town for the last time, going to Penn State. I've seen economic dislocation. It hurts. Schenectady is still trying to figure this out. So when we talk about the need to move beyond coal, believe me, if we don't do it right, there is a massive human cost. I understand that. I know Dr. Mann understands that. I'm not sure if the natural gas guys all do, but this is what happens. And it's not a lot of fun to live through, as I'm sure many in West Virginia understand. Let me just go through a little bit of my background. I'm a recovering weather forecaster, fundamentally. That's not me on the lower right, but it could have been me. I ended up in the Navy to pay for college, and some of my happiest times was basically doing weather forecasting at sea. This is me up in the Bering Sea in January, think deadliest catch, and we were doing things against the then Soviets back in the 80s. Went to NOAA, I was their chief operating officer, and now I'm at Penn State. So let me just talk. I'm a pretty simple person. I've been in the Navy. It's a pretty practical organization, and you tend to just try to boil stuff down into things that work. So I have this very simple three-legged stool of how I think about scientific understanding. And I just want to take a minute or two to let you know why is there do think that carbon dioxide is a major controller on the climate. And it's three things: Do we understand the fundamental theories? What do the observations say? And can we predict it? And if the answer is yes to all three, then you would argue you have alert. The answer is yes to all three. So that's kind of my stool here. And let me just walk through it very quickly. Okay, there's not a test. Dr. Mann would get an A. Everybody else, I'm not quite so sure, including myself. So this is when I started talking about this in the Pentagon a decade ago. Some of my fellow admirals asked me, Titley, have you got religion on this? And I said, no, I just went to the Church of the Radiative Transfer Equation. And as Dr. Mann kind of pointed out, we've known this stuff for a long time. So you had Fourier on the far left in the 1820s, figured out the atmosphere affects heat. You have Tyndall, a Scot. He actually figured out carbon dioxide was, in fact, a greenhouse gas. And by the time you got to the close of the 19th century, you had the guy on the right, Arrhenius, a Swede, starting to do the first global warming calculations. So you had a Frenchman, a Scot, a Swede. As far as I know, they did not go into a bar, but they kind of figured this stuff out. So I say that this is the fundamentals of climate certainty. So what do the observations say? And I don't think anybody on this panel is going to disagree that the climate is changing. So this is from NASA. And this really just shows relative to the 20th century, which would be sort of white, as the years go by, and the years are down at the bottom there, how the temperature is changing. So here comes a dust bowl. Here's the 30s. So you see the U.S. was quite warm, but there were a lot of parts of the world that were still below the average, even when we think of it very hot in the 30s. So here's the 50s, I think the 60s, 70s, the 80s, the 90s. There's still areas you can find below average, but fewer and fewer. And you can see how this moves around. That's that natural variability that we've talked about. But you can see the signal that has been put on top of that. And that primarily is coming from carbon forcing. So the third part, can we actually predict this stuff? So already this name's been mentioned, Jim Hansen. Now this is not the Muppets guy, this is the climate guy. And if this page kind of looks like a Xerox of a PDF, it's because it is. It comes out of a science journal from 1981. And this guy Hansen, who at the time was a young buck scientist, said, hey, let's go see if we can calculate this stuff. So he knew everything. If you can see on that graph, it's on the far left where the observations are. He knew everything to the left of that, the last inch or so of that. All those black lines, we didn't know what was going to happen. Those were his estimates, and he had to figure out how much greenhouse gases were going to come in. So what he basically did is he calculated that, and somebody later, 30 years later, said, hey, let's see how that guy Hansen did. And that's the purple line. That's how we verified. So it turns out that Hansen, who sometimes is thought of as an alarmist in this, was actually too conservative on his predictions. So I've gone through in 2 seconds here, kind of, we have fundamental understanding for well over 150 years. We have dozens. We could talk for weeks about the observations, and we've been able to predict this stuff at large scales for a long time. Just so you know, if we had two people who weren't really quite sure about this, two climate scientists, to show where the science community is, we would have to put that number of people up here on this stage, probably about the same number that's in the audience, about 200. Okay, so when I think of climate, again, I'm a simple sailor. I can only think of 3 things at one time: people and water and change. People, water, change. No polar bears. I'm sorry. I'm sorry if anybody loves polar bears. It's okay. But we will, in the interest of time, I'm not going to talk too much about the individual impacts on the people, the water. I do talk about this, all about the water, but really I want to talk about the change piece of climate. And this has actually come up a couple times. Here's just a slide, comes out of some work by John Englander and others, of the variability that we've seen over the last 500,000 years. And it doesn't really matter which of these 3 lines you look at, whether it's sea level or temperature, carbon dioxide. One, you can see they're all pretty correlated. And yes, up, down, up, down, up, down. And people who study climate in the distant past, we call them paleoclimatists, actually, climatologists, actually Dr. Mann, that's his original field. They can actually explain why we have these. And again, I don't have time right now, but we understand why we have these. But what we had, if you take the very, very, like just tiny slice on the right-hand side, the most recent 8,000 years, you can see, and this is sea level, we've had stability. And when did we come up with human civilization? During those 8,000 years. Now, it's not like the ancient Egyptians sat down and said, hey, we're going to have climate stability. Let's start civilization so we can all carry iPhones around in about 10,000 years. I don't think they had that conversation. But what was happened is we could start planting crops, and they would grow the same place year after year. If we built a port, we didn't find it 10 miles high and dry, in a century, nor under 40 feet of water. So we could set up trade. And we've developed human civilization with over 7 billion people. If we change that, and especially if we change that rapidly, we have to think of what are the impacts. How are we going to do that in a world of 7 billion people? Or can we take some prudent measures to reduce the likelihood of that risk? In the military, we have a saying, if you wait for 100% certainty, you'll be 100% dead. So this is risk management. And if we see that there is a risk, this is exactly what Ronald Reagan did, oh, by the way, with the ozone. He said, I don't know if you science guys are totally right, but if you're right, this is really bad, so let's do some things now. And thanks to President Reagan and many other countries, we're actually making progress on the ozone hole. So it's risk management, and that's how kind of this is looked at. Okay, I apologize for the words, but that's what I have. Again, 3 things. So this is something you may or may not have heard or thought about before. How does climate change impact national security? It changes where our soldiers, sailors, airmen, and Marines have to operate. It changes that environment. I'm guessing many of us are parents or even grandparents in this room, and I'll bet a number of you have sons, daughters, nephews, nieces that are serving in our armed forces today or have served. Our American way of war is we do not fight the home game. We fight the away game. And we want to make sure that our military forces have a home field advantage on that away game. Part of that is understanding the natural environment. And if it is changing, and especially changing rapidly, the military needs to make sure they're ready for it. Second is the threats to our operating or our security infrastructure. Norfolk Naval Base is taking on more and more flooding, and it's not just the base itself, it's the access roads and it's the infrastructure that supports it. The people who make Norfolk Naval Base work live off base. They've got to get there. They've got to live someplace. And finally, if we have time in Q&A, I'll talk about it. Climate change can be a link and a change of events that can make bad situations worse and sometimes catastrophically so. For those of you of a certain age, you may remember the BASF commercial, we don't make things, we make things better. Climate change doesn't make things, it makes things worse. Okay, so first, it's really encouraging to actually listen to the words of our current Secretary of Defense, Secretary Mattis. He recognizes climate change is man-made and it is a risk to national security, and he says he's going to manage that like he manages every other risk in the Pentagon. I put this up here, the IC, and I apologize for the acronym. That's the intelligence community. DNI, Director of National Intelligence Dan Coates, President Trump's appointee to that job, testified before Congress a couple of months ago on worldwide threats. You can look this up. You can find it on the internet. And nobody has to hack it. Page 16, a whole series on climate-related threats to our national security. That is from this administration. So, and it is very consistent with what the intelligence community said 2 years ago, 5 years ago, 7 years ago. So this transcends politics and political parties. What can one person do? Well, I have a llama here, and we can talk more in detail if anybody's curious what a llama is doing in a climate talk, although I'm told it's an alpaca. Somebody came up and it's like, I'm sorry, but I'm going to call it a llama. Learn local action, monitor, and advocacy. And when I say advocacy, talk to your elected officials. Ask them, ma'am, sir, what are you doing to stabilize the climate? It's not a yes or no question, kind of like dating 101. It's an opportunity to start a meaningful conversation. So let me just close with a couple words here. Admiral Nimitz, probably not known to be a huge tree hugger, talks about the importance of taking precautions when you are able to. Nothing is more dangerous than begrudging on your precautions. We see the danger signs. We see the warning signs. Maybe we're wrong, but do you want to bet your life on it? Do you want to bet your children's life on it? Because there's a whole lot of people who have looked at this, and believe me, all the incentive structure in the science community is to come up with a revolutionary theory that totally disproves greenhouse gases. They will name institutes after you for 500 years. Thousands of people have looked for those theories. They have not withstood the test of time. I want to end here. I want to end with this picture of NASA. This country does incredible things when we are focused. You think about Apollo 13, and I think quite a few people in the audience remember that. I was just a kid. And by all means, as I grew up and I read more and learned more about that, those astronauts should have died. They should have died in space. We shouldn't have got them home. We refused to let that happen. Overnight, literally overnight, we mobilized the strength of American science and technology, and we achieved basically what people would thought was the impossible. Okay, climate change is not something that happens in 72 hours, but our country does amazing things when we get focused. We're not focused yet. And part of being focused is taking care of people who get dislocated economically, like in West Virginia, like in Western Pennsylvania, like in Ohio. But that's part of it, to get to not just today's life, but to a better life. And with that, I think I'll end. Thank you very much.
Thank you, Nick, and Spillman for putting this event on. It's quite unique, I think, in many ways. A conversation about climate. Quickly, I was born and raised here on this floating village on the northwest coast of Vancouver Island, was sent to boarding school in Vancouver, where I, as an ecology PhD, became radicalized by the threat of all-out nuclear war and the emerging consciousness of the environment, and joined a small group of people to voyage to Alaska to stop hydrogen bomb testing, which we and many other people, we as the kind of spearhead, did. That was the last hydrogen bomb the United States ever detonated. Here, much later, I'm driving a rubber boat into the first encounter with the Soviet factory whaling fleet. Perhaps Dr. Mann doesn't realize that 30,000 whales were still being killed in the early 1970s. It had really nothing to do with fossil fuels replacing them. And we put ourselves in front of the harpoons and got on TV around the world to protect the fleeing whales, and Greenpeace was made famous as a result of this. I left Greenpeace for a number of very good reasons in 1986 after 15 years in the leadership. This has been shown already. Mine's a little more up to date. It shows that it's up above 400 there. And there's no doubt in my mind that human CO2 emissions are the primary cause of this. Ocean warming may have caused a teeny bit of it. Now you're shown graphs like this with y-axes of only 1.4 degrees in order to make it look like there's been this huge increase in global temperature, when in fact if you put it on a scale that's like between -10 and 100 degrees Fahrenheit, you can hardly notice the 1 degree rise in temperature. This has not been a very significant change in global temperature. The last 300 years is when it started, at the peak of, or the depths of the Little Ice Age. We certainly had nothing to do with the fact that it started warming again 300 years ago after many hundred years of cooling coming out of the medieval warm period into the Little Ice Age. Let's go back 570 million years or 500 million years or so here. What I'm showing you here is temperature and CO2 to the best of our knowledge going back that far. You can see that they are almost never in sync. Sometimes they are completely out of sync, like 146 million years ago there. CO2 goes up, temperature comes down at the same time, then CO2 starts going down and temperature goes up. There was an ice age there 290 million years ago or so when CO2 was very high, and then there was another period where they came in sync, but then when CO2 continued to remain low at that big dip there in the middle, temperature skyrocketed up to a pretty well a modern history high in terms of the 500 years since modern life emerged in the Cambrian explosion. So it's ironic to note that this last period that we're in now, the Pleistocene Ice Age and the Eocene interglacial period, are the coldest since 270 million years. That's when the last ice age occurred. That's why all that ice is on Antarctica and the Arctic, because this is an ice age. And periodically, quite frequently in fact, during the last 2.5 million years, it has descended down to south of the US-Canada border on many occasions. A long-term history of CO2 and temperature, and this concludes the fact that CO2 is not the primary control knob of global temperature. There's actually far higher correlation between shark attacks and ice cream consumption. And that's because correlation is not necessarily causation. Causation requires correlation, but very often strong correlations are the result of a third common factor, in this case, temperature. Because when people go swimming in the summer, they come back to the beach and eat ice cream, and that's when they get attacked by sharks. So just remember, anytime anybody shows you a correlation inferring that it's a causation, do not accept it at face value. Here's a correlation that's true: life expectancy and CO2 emissions. The reason life expectancy, a large part of it, is because of our use of fossil fuels. They are 83% of our energy supply in the world today, and they play a huge role in our longevity, our wealth, and our personal freedom. This is the last 65 million years since the dinosaur extinction that temperature skyrocketed to what is known as the Eocene thermal maximum. This is from a Greenland ice core. I'll show you ice cores from Antarctica later, which go back much further. You can see that we are basically at the tail end of a 50 million year cooling period on this Earth. Just 3 million years ago, the Arctic islands of my country, Canada, were covered in forests with giant camels roaming in them. There was nothing wrong with that climate. It was perfectly acceptable for life on Earth. As a matter of fact, when people say, well, we couldn't live back there when it was so warm because there weren't any people yet then, I think our ancestors came through that, or we might not be sitting in the auditorium tonight. Our ancestors came through more changes over the last 500 million years than you can throw a stick at. Absolutely nothing compared to anything variable that's happening today. As a matter of fact, not one single factor of weather or climate happening today is anywhere out of line with the last 10,000 years. Nothing. And I'd like someone to name me one. CO2 is out of line, but it's not weather or climate. There's CO2 going up at the end there. We did that. Notice the temperature isn't following it. But what I'm looking at here is the 100,000-year cycles of glaciation and interglacial periods. The high points are the interglacial periods. The one on the right is the one we're in now. Note that it is colder than the 3 previous interglacial periods. The Pleistocene is still cooling. Note that they are very much in sync with CO2, the temperature curve. This was the fundamental fraud in Al Gore's film, An Inconvenient Truth. He said, CO2 is causing the change in temperature. These are the Milankovitch cycles, in sync with the 100,000-year Milankovitch cycle, which is the changes in the Earth's orbit, in the shape of it. How would changes in the shape of the Earth's orbit affect CO2 concentrations in the atmosphere? No, they would affect temperature. And temperature would affect the ocean's temperature, and the ocean's temperature determines how much CO2 can be dissolved in it. So when it warms, CO2 comes out, and when it cools, CO2 breathes into the ocean. The ocean has 45 times as much CO2 in it as the atmosphere does. And here is a stretching out the last 50,000 years. You can see that CO2 follows temperature. As we come out of the glaciation from 20,000 years ago, well, 18,000 years is where the low point was there, CO2 fell to 180 parts per million. I'll tell you more about that later. Here is the last T. It's divided into 2 parts. The Holocene climate optimum, where it was much warmer, 2 degrees Celsius or so. What they say is going to kill us all if we allow it to go up 2 degrees from what it is now. And then it goes into the neoglacial period. This means the new glacial period. Note that CO2, the red line, was rising while temperature was falling. Another very convincing indication that CO2 is not the control knob of global climate. And then we see, this is why they call it the neoglacial period. These are charts showing the advance of glaciers. So when it was warmer in the Holocene climate optimum, very little glacial activity. It was a warm enough period to cause the glaciers to retreat, as they had been for the last 10,000 years since the peak of the glaciation. But the neoglacial period, the colder period we're in now, we see glaciers advancing, and the little ice age is shown as the tallest chart there. That was the coldest it's been for 10,000 years, was only 300 years ago. The Thames River last froze over in 1814. And isn't it a bit odd that the world record temperatures, that the warmest recorded was in 1913 and the coldest recorded was in 2010? These are global records. How could that happen if there was such a massive warming going on in the world? And this is what it looked like 21,000 years ago. At the peak of the last glaciation, Montreal, where it is now, was under 3.3 kilometers of ice. This is natural climate change. It occurred by itself. We don't know why. And we don't know why we plunged from the Eocene thermal maximum 50 million years ago into the present Pleistocene ice age. No idea. It wasn't CO2, that's for sure, because for the first 100 million years of the decline in CO2, temperature was rising into the 50 million year Eocene maximum. You've seen this chart. Where it levels off at the top there is where the big glaciers were all melted. And that's basically where the warm part of the Holocene occurred. But it shows it slightly rising from then on for 7,000 years. How could this happen if the sea was rising steadily for 7,000 years, even slowly? This is one of thousands of islands at the equator in Indonesia that have been undercut by the sea's erosion in a calm equatorial climate. Here is the sea level rise in Florida. There is no acceleration. This is expected because we're in the modern warm period. Here is showing that even the IPC rejects the idea that extreme weather events are being caused by either natural or human-caused climate change. First they said it was global warming, then it stopped warming so much, then they said it was climate change, then if you said, well, last winter was really cold, else they said that wasn't climate, that's just weather. Now what do they talk about? You saw the presentation. It's all about extreme weather events. It's changed the goalpost twice since we started with this fantasy. CO2 is the most important food for all life on Earth. That's where the carbon in carbon-based life comes from. Here's where the carbon is. The atmosphere has 850 billion tons, but there's 100 billion tons in carbonaceous rocks, limestone, marble, and chalk. All that carbon came from the atmosphere via the ocean by calcifying marine organisms such as this one that lived when CO2 was at 2,000 parts per million, not just 400 like it is now. And here's an example of many of the calcifying marine organisms that caused that 100 billion tons of carbon to be drawn out of the annual cycle and put into the bottom of the sea, so that here you see CO2 has been declining steadily for at least 600 million years, while temperature has basically got no pattern. It goes up and down, up and down, up and down. CO2 goes one way, down. And if CO2 had continued to go down at the level it was in the absence of human CO2 emissions, this is what would have happened. It was only 30 parts per million above the death of plants at the height of the last glaciation when it fell to 180 ppm. At 150, they die. We have inadvertently reversed the decline in carbon dioxide in the global atmosphere, so it is a salvation, not something to be demonized. Here's what CO2 does when you increase it with trees. It makes them grow twice as fast at double the level. Every commercial greenhouse grower in the world pumps CO2 into their greenhouses to make them produce more food. And here, the top science body in Australia, CSIRO, shows us the greening of the Earth by CO2, and then NASA shows us the same thing. They know it too. And here is the world's energy supply. The greens are against coal, oil, gas, nuclear, and hydroelectric, and only in favor of 1.3% of the world's energy supply. It reminds me of when they said in Vietnam, you have to destroy the village to save it. We have to destroy human civilization to save it, apparently. And that's what would happen if you cut out all those things which are basically 98% of the world's energy. Here's the coal plants being built or planned in the world. China is continuing to build them apace. The fact is, fossil fuels are 100% organic, as in the scientific definition of organic. Organic chemistry is the chemistry of carbon. Organic used in food is a marketing term, nothing to do with science. Produced with solar energy, 100%. They are a product of life, fossil fuels. They are not some evil demon sent here from hell. They produce the two most important foods for life when they're burnt, CO2 and water, and they are the largest storage battery of energy on this planet. So I say, celebrate CO2. It is the most life-giving substance along with water on this planet, and it's doing the world a lot of good. If it ever does warm up because of CO2, it would be a good thing, but it doesn't look like it's having much effect there. And nobody mentioned water vapor as by far the most important greenhouse gas in the atmosphere. It's at least 90% of the greenhouse effect. First, because it's 25 to 100 times the concentration of CO2 in the atmosphere, 1 to 4% compared to 0.04% for CO2. And two, because it absorbs a much wider range of infrared radiation across the spectrum than CO2 does. And water vapor may actually pretty well diminish the effect of CO2 because it absorbs in the same bands. CO2, there is no way that it is any more than a few percent of the greenhouse effect on this earth. And that, I don't know how anybody could argue with that, because it is 25 to 100 times as present in the atmosphere. And that's why I think we should celebrate CO2. And just remember, the bubbles in your beer and champagne are CO2. Thank you very much.
Now it's time for the question and answer session. And Dr. Mann, the first question will go to you since we haven't heard you speak for the longest period of time. Earlier you said that we need to move away from fossil fuels. And my question is, why shouldn't we also move towards clean coal technology, carbon capture technology that allows us to use the inexpensive fuels such as coal while also reducing CO2 emissions to alleviate the problem and still have the benefit of the use of those fuels?
Okay, well, thanks for that question. It's a good question. There is absolutely nothing wrong with capturing and sequestering CO2 from coal-fired power plants. If you can prevent the CO2 from getting into the atmosphere, then, if you can keep the genie in the bottle, then, you're not contributing to the climate change problem. Here's the problem. There is a war against coal. There's a war that is being waged against coal by the natural gas industry. Natural gas right now is out competing coal in the marketplace. It's just simple economics. Now, if you tell coal producers that they have to capture that carbon, they have to bury it permanently beneath the surface of the earth, then that just adds to the expense of producing coal-based electricity. So already coal is being priced out of the market by other sources of energy, natural gas in particular. If you capture and sequester the carbon, if you require that coal-fired power plants do that, they're going to be even more priced out of the market. That's the problem right now. It's just not economic. There's nothing wrong about it in principle, but it's not competitive in the marketplace.
Thank you. Next question is for Dr. Curry. You've previously discussed how difficult it is to address climate change issues with a specific level of certainty. You even coined the frame the uncertainty monster. If there is such a level of uncertainty regarding climate change science, isn't the prudent course of action to err on the side of caution in order to avoid the projected crisis?
The issue with uncertainty in decision-making is that you have to match the decision-making framework to the level of uncertainty. If you're talking about, deep uncertainty, way out there, things that have a very low probability of happening, trying to do a cost-benefit analysis or to figure out what you should do doesn't make sense. And when it's a really complex environmental / socioeconomic problem, the precautionary principle can often set you on the wrong path, where the cure can be worse than the disease. even if you believe climate model simulations, and even if we're successful in meeting the Paris commitments for reducing emissions, we're not going to reduce the warming by more than a few tenths of a degree by the end of the 21st century. And this is even what the climate models say. So, you know, we can't really control the climate by trying to do this. And so it's just a mismatch, and the cure can be worse than the disease. If you spend all this money on the solution that's really ineffective, then you know, hurt the economies, and we're less able to protect ourselves from whatever comes our way. So, and yeah, so you know, you end up with the cure being worse than the disease, and that's not going to help anybody. So it's a very complex problem, and that's why the ideas of climate pragmatism that I put forward, they're what we call, you know, robust decisions that even if the warming doesn't materialize, you've gotten some benefits from whatever you've decided to do.
Thank you. Admiral Titley, the next question is for you. What is the single most significant and reproducible data point that supports the claim that increased CO2 emissions are causing an increase in either the number or severity of extreme weather events?
So there was a report that I chaired as National Academy of Science on attribution of specific extreme weather events to climate change. And what we saw in there, and it's a consensus report, anybody can go Google it there, is droughts and temperature are the two most components, and flooding are really the components that are most attributable, specific attribution. So heat waves, or usually now lack of cold, flooding, and droughts. Those are the components that are most attributable. For science, when you look at overall, like how do we know this, I think I answered that. It's my three-legged stool. It's a combination of, do you have not just correlation, but do you have fundamental understanding, which we've had since the mid-19th century. Do the observations of independent data sets. Let's say you don't believe, for whatever reason, the atmospheric temperatures. Look at the oceans. If you don't believe the oceans, look at the ice. If you don't believe the ice, look at how the ecosystems are changing, etc., etc. How does that all work? And then finally, can we predict it? And can we predict it? And there's been many, many studies show that the only way you can get the climate models to replicate today's climate is by increasing the carbon dioxide. So science is a weight of evidence. If you want proof, go to geometry. But science is a weight of evidence, and the evidence weight, we believe, is compelling.
Thank you. Dr. Moore, the United Nations IPCC is warning that there will be severe, pervasive, and irreversible impacts on Earth if we do not hold the temperature to less than 2 degrees Celsius increase by the end of the century. What will be the impact of a 2-degree increase on temperature?
Well, it would be sort of like moving to Florida, I think. From here, for example, you'd have at least a 2-degree increase in temperature. I don't think half of you would die if you moved to Florida, at least not where your natural end. So I think that is a silly projection and a silly number. The idea of 2 degrees Celsius damaging half the life on the planet is just crazy. You saw what I showed you, how warm it was in the past, and how I have said very clearly that nothing in the present situation of weather or climate is anywhere near out of the ordinary with the past 10,000 years. In fact, the Holocene thermal optimum was warmer than it is now. We know that for a fact, and people lived through that. As a matter of fact, that's when civilization began to flourish. The whole of the Sahara Desert had villages spread across it at that time because it was green. And the cooling that has occurred, which usually brings drier conditions, has brought drier conditions. And if you looked at that graph and the fact that it's steadily downward from the Minoan warm period 3,000 years ago to the Roman warm period 1,000 years ago to the medieval period 500 years ago to the modern warm period now, which began 300 years ago, you will see a steady decline in the peaks of the warming all the way along there. We are actually on the slide down, which will take about 80,000 years, into the peak of the next cold period, the next glaciation. It shows very clearly on the ice cores from Antarctica, those 4 peaks I showed you, that the peak of the interglacial period is at the beginning, and then it goes along and then gradually starts to go down, and for 80,000 years descends into the next glaciation. That's where we are right now by all best knowledge.
Thank you. Dr. Mann, the well-known hockey stick graph has been subject of significant praise and criticism since its release. If you could go back prior to its release, are there any changes to the methodology that you would make based upon the criticisms you received?
Well, thanks for the question. Actually, for 2 decades, we responded to legitimate issues that were raised. Our study was the first of its sort to try to take all these disparate paleoclimate data and reconstruct patterns of past surface temperature on a year-by-year basis. So it was a seminal piece of work, and like any seminal piece of work, there were places for improvement. There was room for improvement. What we spent the subsequent decade and a half doing was developing more elaborate methods, working with the paleoclimate community to introduce a more diverse group of proxy records that can be used for this sort of work. Perhaps the best thing to point to here is a study that was published a few years ago in the premier journal Nature Geoscience. This is the most comprehensive study of this sort, the most comprehensive attempt to reconstruct past temperatures using these sorts of data. More than 80 co-authors from more than 40 institutions around the world using the most comprehensive database. And they produced a reconstruction of temperatures over the past 1,200 years. It's called the Pages 2K project. It's an international project. If you plot their result on top of the hockey stick, it's difficult to distinguish which curve is which. Remarkably, they come up to almost the same identical conclusion that we did 20 years ago. And that's how science works. If you're wrong, others are going to demonstrate that you're wrong. People are going to improve on the methodologies. People are going to use independent approaches, different data, and when it all points in the same direction, and let me add, by the way, that it's important to get things factually right. We can't just state untruths when it comes to the science of climate change. There's room for debate about the implications, about the policies, but let's get something straight. If you actually look at the state of the art in the scientific literature when it comes to reconstructing past temperature patterns, the farthest back we can go right now with global estimates of temperature on century by century time scales to actually reconstruct temperatures on the same time scale that global warming is occurring today. The farthest back we can go right now is about 30 to 40,000 years. And if you look at the leading journals, the nature journals, the science journals, the estimates of temperature over that time frame show that the recent warming is unprecedented. It is unprecedented as far back as we can go. And putting up 30, 40-year-old graphs based on data that would be laughed out at a scientific conference today if you tried to present them, really does a disservice to this discussion, because it isn't true that the Holocene optimum, quote-unquote, was warmer than today. What we now understand was that the changes in Earth's orbit relative to the sun has a different influence on temperatures during the summer and the winter. And if you only look at half the year, which is sort of what scientists were doing, they were only looking at the summer and they were only looking at the high latitudes. If you look at the whole globe, if you look at summer and winter, what you find is that those temperatures were not as warm as today. The temperatures today are as warm as we are able to reconstruct. As far back as we are able to go with these sorts of reconstructions, temperatures today are as warm as they've been.
Thank you. Dr. Curry, can we even have any scientific predictions on carbon dioxide's role in climate change until the equilibrium climate sensitivity index is determined?
Okay. Equilibrium climate sensitivity is a sort of a metric for how much warming would you get if you doubled carbon dioxide in the atmosphere and you allow the climate to equilibrate for some hundreds of years. There's a great deal of uncertainty in that parameter. The latest IPCC report gave a likely range between 1.5 and 4.5 degrees centigrade, and that range has been pretty much unchanged for some decades now. But there's still a lot of evidence supporting values outside those ranges on both ends. Okay, so there's a great deal of uncertainty. Now, climate models have an average equilibrium sensitivity of about 3.2, and it's a much narrower range, and it's on the higher end of that. And so when you project into the 21st century with these climate models, you're really only getting the high end of things, not what it would be if the sensitivity was on the lower end. So this is sort of a logical inconsistency, in the conclusions, in my opinion, because there's this great deal of uncertainty about equilibrium climate sensitivity, but the climate models are on one end of this, and the projections are then, on the high end relative to what the lower values of equilibrium climate sensitivity would suggest. So it's still a lot of uncertainty there.
Thank you. Admiral Titley, can you rank by eminence the strategic threats to Homeland Security posed by climate change, and if able, provide a rough timeline of when you believe those threats are likely to materialize?
So it's always, what is it, Niels Bohr and many others said, predictions are tough, especially when they're about the future. So ranking these gets into the various time frames. So long term, the big threat is sea level rise. So if we do not really change our way we're putting CO2 into the atmosphere for the rest of the century, we are most likely locking in roughly 25 to 30 feet, give or take, of sea level rise. Now, that's not going to happen instantly, but that's like in a couple of 100 years or so. So when the Navy tells me that they're going to raise the piers at Norfolk by 3 feet or so, I say that's interesting. What you really need to be thinking about is, are you going to build your mid-Atlantic naval base at Yorktown or Williamsburg? So I don't know if anybody here owns property in South Florida, but with that kind of sea level rise, the southernmost point in Florida is Orlando. I could go on and on. So there's a threat to our infrastructure. There's also a threat due to the unplanned and forced migration. So you probably know here, Syria and the refugees coming out of Syria shook the EU to its core, the European Union. That was with 1 million refugees. If we continue business as usual and raise the seas, we have plenty of ice to do so, that will put roughly 500 million, 500 million people in play. So we've heard tonight how the climate's been much, much warmer, much, much colder, and we're all here, so clearly Homo sapiens made it. That's a true statement. How many people were on the planet at that time? Maybe 1 million? 1 million. That's probably like the population of West Virginia, total, for the whole globe. We are dealing in the real world, and what the defense and the intelligence communities look at is the real world. And that is a world of nearly 7 billion people. How do we manage these changes with 7 billion people? That's the big issue.
Thank you. Dr. Moore, what is the single most significant, reliable, and reproducible data point that supports the claim that man-made CO2 emissions are not affecting climate change?
I didn't say CO2 emissions were not affecting climate change. I said that it is an insignificant effect. CO2 is a greenhouse gas, but it is in the atmosphere at 0.04%. How can something in the atmosphere that is invisible, tasteless, odorless, colorless, at 0.04% be the most powerful agent in the universe at this point in time? Obviously, the climate changed dramatically throughout history with nothing to do with CO2. Those things that caused those changes have not gone away. They are still here. And CO2 did not cause the change in warming that started 300 years ago coming out of the depths of the Little Ice Age. Even the IPCC says mid-last century. That isn't even a century that they say we've been the main cause of climate change. The problem with the Intergovernmental Panel on Climate Change, they get some things right. They do not attribute extreme weather events to anthropogenic climate change. But the extremists do, the alarmists do. They just carry on as if, as if the IPCC didn't say that, but they did say it. And it's really what they don't tell you that is more important than what they tell you. Like, for example, just now, Dr. Mann has said the Holocene thermal optimum was not warmer than it is today. Then how come the glaciers are advancing so much more now than they were during that period? Does a colder time make glaciers advance less? Surely not. The neoglacial period is a period of advancing glaciers. The glaciers advance most. These are data points. The data point is the Little Ice Age. Glaciers have advanced more than they have for the last 10,000 years. That means it's colder. Surely to goodness anybody can figure that out.
Please, no comments from the audience.
When they recede, it's warmer. When they advance, it's colder. That's what glaciers are made from, cold.
Thank you, Dr. Moore. I'm going to ask one last question for the entire panel, without much commentary, just see if you can. If you can't answer, that's fine, and then we'll go into closing statements. What is, in your opinion, the optimum level of CO2 in the atmosphere for plant growth without harming climate change? Dr. Moore. I'm sorry, Dr. Mann.
So thanks for the question. This is a question you often hear, and you sometimes hear statements by contrarians in the climate change debate that, well, who's to say what the optimal CO2 level is? Who's to say what the optimal temperature is? And there's a simple answer to that. The optimal CO2 level and the optimal temperatures are those that persisted, that existed, as we developed a civilization now of 7.5 billion people who are dependent on the stability of our climate, who are dependent on the climate remaining somewhere close to where it was when we developed that civilization. So that's the bottom line. There is no optimal temperature, there is no optimal CO2 level, other than there is a CO2 level and there is a temperature that we developed our civilization around. And if temperatures change dramatically away from that, we will see the sort of mass unrest, the increased competition for resources and conflict that David Titley was talking about. We are dependent on the stability of the environment that we develop civilization in.
Let me ask it a different way, because I'm trying to pin down just a little bit. At what level would you feel comfortable that there was no longer a threat to rising temperatures and the issues that are being discussed here?
So right now, if we allow CO2 levels to persist, say at the level they're at right now, a little over 400 parts per million, if you look back in geological history, what we find is when CO2 was as high as it is now, and we allowed the climate simply to adjust over centuries to that CO2 level, you're talking about sea level rises of 60, 80 feet, 100 feet. So we have to get CO2 more or less within the range that doesn't allow that to happen. The best estimates are that that's probably somewhere around 350 to 380 parts per million CO2, which is to say we've got to bring CO2 emissions down, and ultimately we need to actually bring CO2 back down out of the atmosphere. And there's some technology that could potentially be used to do that in the longer term.
Thank you. Admiral Titley, do you have an opinion on that?
Okay. I've talked at some length about the stability. I talked about there really is no ideal climate, unless anybody here in the audience is from San Diego, Honolulu maybe. Okay, you guys have ideal climate. I'm up in Pennsylvania. I don't see the sun between November and March, but it has been a stable climate, and I think I've kind of beaten that horse in there. Oh, by the way, I want to find these advancing glaciers because I'd love to see them. It's all like the ones I've seen, but that's another issue. Probably it's in the mid-300s. It's somewhere in there. It's probably at something under 400. And again, it's the sea level rise concerns me because it moves tens of millions of people. And if you have good governance and you really think about it, you can do this with only moderate disruption. But as we've seen in Syria, when things really fall apart, even a relatively small number of migrants, for whatever reason, and there is a climate threat, it's not caused, but there is a climate threat in Syria, that this creates security issues writ large. So I'd say probably in the mid to upper 300s.
Thank you. Dr. Curry.
Well, plants clearly like more CO2. In terms of the climate, we really have no idea. I've always been puzzled by why people think that somehow pre-industrial conditions, say mid-18th century, was sort of the baseline. Well, that was low CO2, but it was really, really cold. It was in the, think Valley Forge. I mean, is that the climate we want? No. And climate is not stable. All of that happened independent of CO2 high or low causing anything. There were other causes besides CO2. CO2 might have responded. So climate fundamentally isn't stable. So we just have to learn to live with whatever kind of climate we get, and to the extent that we can try to control it, it's probably fairly futile. So that's my comment.
Thank you. Dr. Moore.
Trying to control the level of atmospheric CO2 is a stupid thing to try to do. We're not going to succeed. We're not going to end fossil fuel use by 100%. And the two answers that were in the mid to high 300 ppm would mean that we would not only have to end the use of fossil fuels entirely tomorrow, but we would have to stop making cement, because cement manufacturing is 5% of the CO2 emissions. And even if we just continued with 5% of the present CO2 emissions, they would continue to go up much more slowly than they are now. But I'm happy with that, because that means when the fossil fuels do run out hundreds of years from now, that as long as we keep making cement, we can keep the CO2 from going back down again to the life-threatening state it reached during the peak of the last glaciation and the one before that and the one before that, when upper alpine forests died. And I think the general has mixed up the time scale here. I didn't say that the glaciers were advancing today. They've been retreating for 200 years or so, because we're in the modern warm period. When they advanced more than they ever have in the last 10,000 years was during the Little Ice Age, which peaked in 1700 or so, in conjunction with a quiet sun, by the way, the Maunder minimum, which is another whole subject we haven't discussed, is really very much is the effect of the sun on the climate. Some people say it's the sun, stupid. But the truth of the matter is CO2 and plants is what's important here. Plants are the basis of all of our life. Every animal life and every non-photosynthetic life on Earth is based upon plant life. And plant life is based upon CO2. And plants evolved in a CO2 level of thousands of parts per million.
30 seconds.
And even today, greenhouse growers double and triple the level of CO2 in their greenhouses, because that's what plants prefer. And if sea level rises, you're not going to have to run. You have two decisions to make if the sea comes up, like it did 420 feet since the last glaciation. You can either go higher or protect the coast. Where it's flat, it probably makes sense to go higher. Where it's steep, it probably makes sense to go up. We can build infrastructure so fast these days, and just hire the Dutch, and you'll have the,
Thank you, Dr.
23% of their land is under sea.
Thank you. All right. Time for closing statements. Going on, Dr. Mann. 2 minutes.
Okay, thanks. So I began, with my presentation making the point that there is an honest debate to be had about what we do to deal with this challenge. It's one of the greatest challenges we face as a civilization, and as David has alluded to, there are ways forward that will allow us to prosper economically and deal with this problem at the same time. Now, That having been said, there really isn't an honest debate to be had about the basics as assessed by the U.S. National Academy of Sciences. This was an organization that was created by a Republican president, Abraham Lincoln, to provide an assessment of policy-relevant science, and today is sort of the gold standard when it comes to assessing the state of scientific understanding. As David said earlier, if you look at what the National Academy of Sciences has had to say about the linkage between climate change and extreme weather, there are clear linkages in several cases when it comes to extreme rainfall events, flooding events, droughts, and heat waves. There is decisive science, despite what some of the other panelists may try to convince you. And there's been a lot of mud thrown on the wall, a lot of talking points, a lot of claims that have been made that simply don't stand up to the slightest bit of scrutiny. I would point out to the audience that there is a wonderful website called skepticalscience.com, and you can go to that website and you'll see that a number of the talking points that our contrarian participants here have sort of introduced tonight are actually among the 150 or so leading contrarian myths and talking points when it comes to climate change. And you can go to the site, you can see what the myth has to say, and you can see what the science actually has to say, and you can see the peer-reviewed scientific literature behind that. So I would encourage you to do that. There's some pretty compelling arguments that have been made against the scientific consensus. They're all wrong. Go to Skeptical Science, get the facts. Thank you.
Thank you. Dr. Curry.
Well, you've just seen the climate science madhouse in action, okay? This is a very, very complex issue, both the science and the socioeconomic impacts and the options for policy response. My concern is that we have vastly oversimplified both the problems and its solutions. And by insisting that there is no debate about the science, by insisting that there is only one path to solving this, is a recipe for disaster. We will be surprised. We will make mistakes along the way. And fundamentally, we just need to learn to live with whatever is going to come our way. This is what human societies has always done. This is what ecosystems have always done. And it's the job of scientists to try to understand all this and be as unbiased and objective as they can, and to learn through disagreement, and to really push the knowledge frontier by trying to enforce this overly simplistic so-called consensus. We're not going to get anywhere. So we need to open up the debate on both the science and the policy options if we're going to make any progress on this.
Thank you. Admiral Titley.
Oh, where to start? In the Navy, we would call this a target-rich environment. Let's see. If you want something to read that is very, very accessible, that will give you the facts, Google What We Know by the American Association of Advancement for Science. It's about 8 pages, has figures, and as citizens, if you read that, you'll know everything you need to know as an informed citizen on climate. And it's got the facts, and it's very, very well written. So let me start there. I would agree with Dr. Curry. There are surprises. Unfortunately, those surprises are usually on the negative sense. I would argue that now, since we have brains and we have supercomputers and we do have some ability to look into the future, however imperfectly, we don't need to just live with it. Live with it is what Europe did with the plague in 1350. They did live with it at the cost of about 30 to 40% mortality. We don't have to do that anymore. Let's be smarter than that. We are an energy society. Nobody here that I heard is advocating giving up energy, although I heard some strawmen to that effect. What we are arguing for, or advocating for, is to how to transform the energy so we have abundant, affordable energy that does not do long-term harm to our climate. Our defense community and our intelligence community in this administration take this issue very seriously. I think we should too. And finally, I'll just end with what I closed with my TED Talk. The ice doesn't care what we say on this stage. It doesn't care who's running Congress. It doesn't care who's in the White House. It's just films. Thank you.
Thank you. Dr. Moore, 2 minutes.
In 1970, there were approximately 6,000 polar bears. Today, there are somewhere between 25,000 and 30,000. That is a fact, and they still say they're going to go extinct. The word consensus, when used in a sentence with science, is false, because consensus is a political and social word that is a different arena than science. Science is about observation and replication, period. It is not about how many people are willing to jump off a cliff with you. It is not about lemmings. It is not about sheep. It is about individuals like Galileo, Darwin, Mendel, Newton, Einstein. When Einstein published his theory of relativity as an obscure patent clerk, he was scoffed at by the rest of the physics community to the point where 100 physicists published a paper saying he was wrong. When asked what he thought of that, he said, why 100? One would do. Because that's how science works, with individuals making discoveries. It's very seldom that 17,000 people come to the same brilliant conclusion all at the same time. That doesn't happen. This has become some kind of religion. Even the Pope is into it, right? Original sin. Humans are original sin. We're sinning against the world and nature by burning fossil fuels. That is a lie. And it is not honest to say that this debate should be squelched. Because in science, if you say that, you are an activist, not a scientist.
Time. Thank you. Well, we ended with a little bit of fireworks. Again, I'd like to thank the panel, the audience, and once again, we're going to have a round of applause for our world-class